Fancy meet computers. All 5 of you. Hooray! Let me just check to see if my other microphone started working mysteriously. Useless. So, how was your weekend? Personally, I've had a cold all weekend, so I haven't been having a huge amount of fun, but you know, it is what it is. So, in terms of announcements, some of you were asking for some practice material for the upcoming midterm. So we have now added to the Avenue stream said practice material. There we go. It's not a lot of questions, unfortunately. Essentially what happened, my plan was to make the entirety of last year's midterm into a set of practice problems for this year's midterm. But as it turned out, I needed some of those questions to supplement assignment 3 because assignment 3 was a little bit on the anemic side. The regular Eng weekend of work. Yes, I hear you. It's kind of funny. When I was undergraduate, I kind of got into the habit of considering my weekend to occur entirely on Thursday, which is kind of a habit that has become difficult to shake into the rest of my adult life. My body still thinks that Thursday is like the only weekend I get is going to be on Thursday, you know. But so anyway, so yeah, so there are some practice questions that have been posted. I apologize for not having more of them, but it is what it is, you know. In addition to that, there's assignment 3, which you guys should be working on this week. So, you know, you may assume from the fact that the assignment 3 document has been supplemented with questions from last year's midterm, that, you know, assignment 3 is going to be very good practice for the midterm. It's going to have, like, probably roughly the same types of questions on it. So what does the midterm cover up to, and how many questions will be on the midterm? Again with the asking me how many questions there will be on the midterm. My goodness. It doesn't really matter how many questions there will be on the midterm because there are easy questions and there are hard questions. I could tell you there are going to be 20 questions, but if they're all multiple choice, you know, it doesn't really matter. So, roughly speaking, up to the end of topic 6. So, you can expect pointers to be on there. You can expect dynamic memory allocation to be on there. You can expect the sort of arrays in general to be on there. You can expect, you know, functions and function manipulation to be on there. You can probably expect a question on recursion. So it's kind of like the first half of the course is going to be on the midterm. But yeah, so it goes. How would you do multiple choice and submit it in GitLab? Well, it's pretty easy, actually. The way I've done multiple choice in the past is I've had the students write a series of C functions that return a character which is whichever answer they want. And that way we can integrate it into the existing auto-grading system. But to be honest with you, I don't know if I'm going to do the multiple choice this time, because I just don't think it's that useful. There's a part in the there's a part on the accreditation requirements for this course where I'm supposed to test you on how well you understand compilation. To be completely honest with you, one of the advanced topics that we're going to be covering in this course is makefiles. So I was thinking that I would just get you guys to write a makefile for the exam or something like that, and that would show very clearly whether or not you know how compilation works. So, you know, I think I'm going to test it that way. Last year I asked a bunch of, like, multiple choice questions about the compilation process, which, like, since it was an open book test and those were primarily knowledge questions, pretty much everybody got it, like, 100% correct, which is, you know, not useful as a metric of whether or not people understand it, you know? Because presumably there's at least one person in the class who doesn't understand it, so if everybody gets it correct, that means it isn't hard enough. But, yeah. Anyway, so we were talking about strings. So let's continue to talk about strings. And, hopefully we'll be able to finish off this, this topic this week, certainly. So, yet more functions. So, we talked about string concatenation before. I've got a handy little chart coming up here in the slides that does all of these string operations with rough Python equivalents. And you can see that string cat is the equivalent of the Python plus sign for concatenation operation. It just uses pointers because, of course, this is C and everything uses pointers in C. String error is kind of fun. It accepts an error number and finds your computer or compiler's corresponding error message and returns it. You can imagine this would be very useful if you were building a compiler. Less useful for sort of your garden variety program. String len, sterling. This accepts a string and produces the number of characters in it, null character excluded. Remember, all of these things are watching for the null character being at the end of the string. So if you even do something relatively simple like measure the size of a string using the string length function, unless that null terminating character is in there, you're now facing a situation of possible segmentation fault, because it will read over the allocated memory into unallocated memory, and it'll just keep going until it hits a 0. And you might hit a 0 quickly, or you might not. And if you don't, you might hit a seg fault. I'm sure that you guys have been getting seg faults, yeah? So, if you ever need to tell if two strings are the same string, you should try the string comparison function. So you've got two types, string comp and string ncomp. Similarly to how pretty much all of these have an n version that only performs the operation over a set number of characters, with string ncomp you can perform string comparison over just a couple, just however many characters you specify. Inputs are generally the same as previously. This compares the characters in each string sequentially and returns 0 if the strings are the same, a value less than 0 if S1 is quote-unquote less than S2, and a value greater than 0 if S1 is quote-unquote less or greater than S2. In this context, I'll answer your question. Let me finish the slide. In this context, strings are ordered by the ASCII values of their characters using alphabetization rules. This is also known as lexicographic ordering. So, or lexicographic ordering. I think I may have misspelled that. Anyway, so the idea is it's dictionary ordering. You compare the first character. Actually, I believe it goes by ASCII. Yeah, ASCII values themselves. So if you'll notice in your ASCII code, or in your ASCII table, boop. You'll notice in your ASCII table that all of your uppercase letters occur before your lowercase letters, and that in general, these guys are in alphabetical order once you get into the sort of block of them, and that the numbers are prior to any alphabetic character. This means in general that words that have a capital letter that start out front are going to be ordered as being less than words that have a lowercase letter out front. So, and if you hit an instance where the first two characters of the two strings are the same, it will say okay, and then it moves to the next character in the sequence, and then continues to compare in that manner until it finds a difference, and then it calculates ordering on that basis. And that's how a dictionary does it, and that's how we do it. So, isn't a null termination automatically inserted at the end of an array, or do we have to insert it manually? So, excellent question. Null termination is not inserted automatically at the end of an array. It is automatically inserted when you use a string literal, right? So, let's see here. Get it. So, for example, if I were to say hello, the compiler knows that I probably meant that I want a null terminating character at the end of that, just by virtue of the fact that I've enclosed it in double quotes. If, on the other hand, you are, and I don't know why you would do this except to prove a point, such as I am currently doing. If you composed a character array using regular array notation, you know, the whole reason that the double quote notation exists is because it's way too cumbersome to enter strings like this. It's just way too many characters. You have to insert the null terminating character manually if you're doing it this way. But again, I don't have any idea why you would ever do that. The trick to all of this, however, is if you're setting a variable, if you're storing this guy in a variable, there's like two ways to do it. The preferred way is to actually leave the square braces blank, because then the compiler will automatically calculate however much room it needs for the literal that it's being assigned. And that's actually true when you're using curly brace notation as well. So if you were to do something like this, everything would be hunky-dory. However, if you're manually assigning the size of this array, then you have to include the null terminating character. So 1, 2, 3, 4, 5, 6 elements would be the correct number. If you were to have 5 instead, it would just truncate the initializer to whatever the size of the array you have is, which means you would lose the null terminating character, which means you're in precisely the segfault territory that I was describing previously. So, we have now a rapid-fire round of searching algorithms which we can apply, and one very interesting one, which is called tokenizing. So, strchur locates the first occurrence of a character C in the string S. If C is found, a pointer to C in S is returned. Otherwise, a null pointer is returned. So this is kind of like Python's in searcher, right? A little bit like in, the in keyword. String C-span, which is not, it's not C-span that you watch to watch the House of Commons, or is that in the States? Is CPAC, I think, in Canada, and C-SPAN in the States, possibly. I don't know. Determines and returns the length of the initial segment of the string S1, consisting of characters not contained in string S2. So it's like, while character in S1 is not in S2, increment the counter and then return the counter. String span is the same, but inverted, so it's only counting characters that are in the strings S2. String pbark, I don't know how to pronounce these, locates the first occurrence of the string S1 of any character in S. The first occurrence of the string S1 of any character in string S2. So it's like a string character, but with multiple characters. String rchar locates the last occurrence. So that's like searching from the back to the front. String locates the first occurrence of the string S1 in the string S2. So, for example, that would be something like, if your first one was hello world, and the string you were searching for was like whoa, then you would get, a pointer to this guy. And interestingly, string token. So string token is one that I recommend actually learning how to use. You'll find it to be extremely useful when you guys tackle assignment 4. So string token, string token is meant to be called multiple times in sequence, and it breaks S1 into a series of tokens. So these are logical pieces such as words in a line of text separated by the characters contained into the string S2. So it's like the Python split method. So for example, if you were dealing with like CSV data, something like that, you could tokenize on comma, and the it would return to you, like first it would return 1, then it would return 2, on the third call it would return 3, etc., etc. It would split this guy up based on whatever separators you provide. So the first call contains S1 as the first argument, and subsequent calls to continue tokenizing the same string contain null as the first argument. So this is unlike a lot of functions, this is one that keeps internal state. It's almost like you can think of it in the same way as you think of file streaming. A pointer to the current token is returned by each call. If there are no more tokens when the function is called, then null is returned. So you can see that C uses pointers all the friggin' time, man. So here is a table with equivalent Python in operations. So str to L is the equivalent of integer conversion of a string. snprintf is string conversion of an integer. String copy is the same as copy.deepcopy, which, if you didn't know this about Python, that's the way that you break aliasing references. That's one of the ways of breaking aliasing references. So string cat is the plus, string length is just len. String comparison, you can actually use comparison operators directly on strings in Python. String char, string character is the same as index, and string token is the same as split. So, question. What is, you have an int array like 1, 2, 3, 4, 5, 6. How do you insert the null termination? You don't need to, because it's an integer array, right? Null termination is only really interesting for strings because, well, it has to do with the encoding of the null character. So the null character, in terms of like its ASCII code, you can see it's the first one, right? So it's 0. 0 is the null character. So when you're talking about characters, you don't really use a 0 value unless you're, unless you're doing something with null termination. 0 isn't used except in this type of circumstance. Whereas, with an integer array, 0 is a perfectly legitimate value that you may wish to keep in your array. So, you can't use it as a special code for end of the array, right? It would be useful if you could, it would certainly be useful if you could have a particular, some sort of special code that designated the end of an array. That's why many languages, more, later and more highly evolved languages than C will often, use such characters in their internals to designate what the end of a data structure is so that the programmer may not exceed it. But in C, we are dealing only with primitives. So, with strings, it's getting a little less primitive, but an integer array is still a very primitive type of data structure. David asks, so I can't have a 0 in a string without it terminating it. Yes, actually. If you take the word 0 out of that sentence and replace the null character with it, then that works. Remember that with the ASCII chart, right? 0 actually has it has an encoded value of 46 or 48, right? So, if you were to insert the null character yourself, like in the middle of a string, if you were to print this off, it would print hello, period, and then it would stop because it thinks, oh, this is the end of the string. I'm not going any further than this, right? It doesn't understand that there's any more string that's been allocated. It stops at the first null character that it hits. But of course, this is different from a 0, right? The 0 character doesn't stop a string printing, right? Because it actually has a encoded integer value of 48, not 0. Yeah, so it's really interesting. If you want to, you can set up a character array, some string by using the ASCII codes themselves. you know? Like, you can totally do this, and the fact that you're like storing it as a character, that'll like chop it up so that it's the correct size, and then if you print this as a string, it'll work. You don't have to write a string in characters. You can use numbers to do it if you want, and then, you know, the equivalent of that would mean that like the equivalent of null termination is that you would have a 0 at the end. Obviously, nobody ever does this because it's like, why would you ever? What would be the use case for this, you know? But it's interesting to note that C is capable of being used in this manner, right? I suppose if you wanted it to be very difficult for anybody to understand your code, you know, like deliberate code obfuscation, perhaps. But yeah, so that's kind of, that's how that goes. If you don't mind, I think I need to just grab a Kleenex and evacuate my nasal cavity. I'll be right back. Alright, so, surely this is generalizable. So, given that in C, data types as a concept are somewhat ephemeral, it should be the case that the above expressions on character arrays... Welcome back. I wasn't gone that long. I hoped that I had kicked this. I was hoping yesterday that I had kicked the cold, but, you know... Yeah. Yes, I do wear pants while I'm streaming. That's, I do, yeah. I don't know. It's not like an Anchorman situation going on here. You know, it's funny. I think, like that, the whole not wearing pants below the desk thing figured quite prominently in the promotional material for the movie Anchorman, but I didn't... I watched that movie not too long ago for the first time with my wife, who's a fan of Will Ferrell, Colin Farrell. Colin Farrell was his dad, who was in MASH. Will Ferrell is the younger guy who's now getting kind of old, but he's still doing movies. Anyway, the whole not wearing pants below the desk thing was it featured a lot less in the movie than I expected it to, proportionally to how it figured in like the promotional material. But you know, it is what it is. It's a good movie. I enjoyed it. I think it's one of his better movies, actually. Anyway, so yes, so we have all of these operations on char stars. It would make sense to have these types of operations on other data types as well. I should explain, though, what I mean when I say that data types are somewhat ephemeral. So, a lot of you will be used to the sort of way that data types are handled in, you know, other programming languages like Python and, you know, Java or C# or pretty much any programming language that you've ever used that's not C should have a more, you know, they'll do data types very differently than how C does them. I've mentioned this in the past, but it bears repeating because it's very important. It's important to know that C is doing this, right? C doesn't really care about data types as we care about data types. It doesn't really care that, you know, some variable is an integer or a float, you know. it cares somewhat about floats, but particularly between characters and integers, there's really not a huge deal of difference between the two once you get into, like, once you get under the hood a little bit. Basically, the only thing that C cares about with respect to these sort of directly interpreted types is it only really cares how big the thing is. The only purpose, really, of declaring an integer as an integer is telling C how many bits to allocate to it. Otherwise, it's like, you can easily interpret, like, characters as, integers. You can use integer subtraction over characters in order to find, like, how many characters forward or back one letter is from another, with respect to ASCII. You can easily, do that type of operation because, C, like, the only reason that a character is a character really is because you choose to print it as a character, it's a string because you choose to use it as a string. Otherwise, it's just an array of really short integers, right? But, sorry, Prof, I'm still confused if we need to include null termination at the end of integer arrays. Do we only have to insert it manually if it's a string array? You shouldn't ever have to add it manually. You just have to allocate enough room for it. If you needed to end integer arrays with a null terminator, I would have told you that when we were talking about int arrays. I wouldn't have let you get this far in the course without having given you that vital information. So no, you don't have to worry about null terminators at all, unless you're talking about strings, right? And with strings, so long as you're using the double quotation notation to initialize them, and so long as you remember to either allow C to determine itself how much room to allocate, or then you're fine. But if you are allocating if you're allocating the size of the integer, or if you're allocating the size of the string manually, which you will occasionally have need to do, especially if you're doing, like, input buffers or something like that, you need to remember to leave enough room for the null terminator. It's kind of an edge case, but you can get caught on it if you're not aware of it. So that's why I keep saying it. So anyway, rather than accepting character char star pointers, these functions use void pointers instead, which means that they're interested in you determining what the type is going to be by casting. So the operations we're about to discuss are also contained in string.h. So we've got memcopy, we've got memmove. Memcopy is basically the same thing as string copy. I'm not quite sure what the difference between memcopy and memmove is. It stores it in some intermediate place. Memcomp compares the first n bytes of object. So if you want to compare two integer arrays, memcomp is the way to do it. Memchar, first occurrence of the integer C, converted to an unsigned character in the first n bytes of the object pointed to by S. So yeah. So basically these are just, again, pretty much the same operations. Well, slightly different operations, but applied to general arrays, not just specifically strings. So, now we're going to talk about formatting. So formatting is like super, super, super useful in C. I'm thinking in particular about a question on assignment 4. There's one question on assignment 4 that is essentially a question on string formatting. And if you use the formatting tags to perform the question, you can do the question in about 8 lines of code. And I have seen, last year when I was helping people out with that assignment, I definitely saw at least one student come up with wrote a program that was 150 lines of code to have the same effect as, my sort of solution program, which was 8 lines of code, which, kind of contributes to, that kind of contributes to the test writing time for sure, at that point it would have been the final exam. But, so it's kind of interesting, right? Because we're definitely to the point where, after about probably topic 6, you have now enough information to program anything that you may wish to program in C, right? There's nothing further that I have to teach you that is like fundamental constructs, except for structures that we're going to talk about in a little bit. But basically the entirety of this lecture is like, okay, so here's a library to do this, right? So that you don't have to do it manually. And a lot of people, I find, rather than learn how all of these library functions that I'm throwing at you work, a lot of people will make recourse to their existing knowledge base and essentially perform all of these operations using if statements and while loops, and comparisons and just like programming. They will program these problems away. Will we be coding graphics at all in this course then? No, this isn't really a course. There's no real point in doing graphics in C. If you were going to do graphics in any language, I would recommend basically any language other than C. So now, towards the end of this course, we're going to do a little bit of assembly programming, which is moving in the opposite direction. It's moving even further away from the GUI and back into the bowels of the operating system. But anyway, so the moral of my story is, while it is possible to perform all of these functions that I'm speaking about using only your knowledge of if statements and while loops sprinkled in with some knowledge of how pointers work, you can save yourself a hell of a lot of time, both on an assignment and on a test, by using these functions that I'm giving to you to their full effectiveness. There's no point in redoing the work of the standard library, and to be completely honest, this student who spent so much time on this 150 line re-implementation of standard library functions, it's like, well, I'm sure you learned a lot from doing that, but I feel bad for you for the amount of time that you spent on that when you didn't need to, So please use the library functions. Especially assignment 4, it gets, in order to accomplish what we want to accomplish in that assignment, it's going to be necessary to use these library functions if you want to accomplish it in a reasonable amount of time. Can you import non-standard libraries? I would prefer if you stuck to the standard libraries, because we have to be able to compile your work without knowing, it's tricky enough with all of you people doing stuff on Windows when we're trying to compile things in a Linux environment. I would prefer if you stuck to the standard libraries. Okay? The standard libraries are really all you need, right? And it's useful to learn the standard libraries because they're standard, so they're everywhere, right? You don't have to perform all kinds of fancy operating system manipulations to be able to find them, you know. But anyway. So, formatting. What can't it do? Up to this point, we have only briefly touched on the advanced features of the string formatting tag %. So basically, this whole section is going to be on how to use this guy properly. We will discuss the following features: rounding of floating point numbers and displaying a specified number of decimal places, aligning columns of numbers, right and left justification, exponential formats for floating point numbers, fixed field widths for various data types. All of the format specifiers we are about to discuss are used in printf, scanf, and and their cousins. So, you may not have realized this, but when you use this guy, this is shorthand for standard library functions. So let's learn how to use it. So first of all, we all know that the thing you start off doing with printf is you start off specifying the data type of the thing that you're wanting to print, right? So let's just review those quickly. D is signed decimal integer. I is signed decimal integer, but this has a different purpose using scanf. O is unsigned octal. U is unsigned decimal. X is unsigned hexadecimal. Yes. H, L, or double L. If you place these before any integer conversion, that indicates short, long, or long, long, respectively. These are length modifiers, so you add them to any of these guys. Alright? So, for example, if we have, good example, 2 billion, or whatever this is. So, with literals, it's kind of interesting. With literals, in order to get a literal of that size, you actually have to put the L suffix on the literal itself. That tells the compiler, listen, may be a literal, but it's not just a regular integer. I want it to be a long integer, so please allocate a space for a long integer here. So that's what the L is for. And if we print it, you can see that it prints all of its data correctly. If you print it, so you can do interesting things, like you can see what the underlying representation of negative numbers are by printing a negative number as an unsigned integer. You get some long number, right? This is interesting because as we're going to touch on, I think in the next lecture, in the next topic, as we're going to touch on, negative numbers are stored in a numerical format known as 2's complement, which essentially means that -1 in signed integer arithmetic is all ones at a binary level. -2 is you subtract 1 from -1, right? So it's like all ones except for the last one, which is a 0. Then you subtract 1 again from it, etc., etc. So when you have like certain 2E04 crossover, there we go, 2's complement, there we go. I think that... I hope I'm not thinking of one's complement when I'm saying this, but I'm pretty sure that's how it works. Anyway, so that's why you get wraparound, right? If you, so it's kind of like intentionally using wraparound, but like, you know, when you have, like, the largest, like, the most negative number, and then you subtract 1 again from it, you get the highest possible positive number, right? So that's roughly how 2's complement works. But we'll have slides on that eventually. So if we have floating point numbers, we can use either E, F, or G. E prints it in exponential notation, that is to say in scientific notation. F is in fixed point notation. So if you, like, that's just like regular decimal places. And if you want the computer to intelligently select between scientific notation and floating point, fixed point notation, then you use G. I believe if you have a number that is like out, like it's far enough away from the decimal place by, I think, 6 significant figures, it swaps itself into exponential notation. So yeah. So you can see printing various numbers in various formats you know, negative large floating point number gets printed E plus 006. So this is, you know, this is the way that C does floating point notation. If you've never seen this before done in this particular manner, you will eventually come to realize that this is very common in computer systems. E means times 10 to the. So, you know, in the same way that scientific notation is like, you know, speed of light is like 2.89 times 10 to the 8th, I think. Somebody can fact check me on that. You know, the times 10 to the is represented in computer speak with just the character E. You can capitalize E by capitalizing the tag. So, and you can see that this is a large enough number, so G is putting it in fixed or in floating point scientific notation. So, E and F show 6 digits of precision by default. F will always print at least 1 digit to the left of the decimal point. So, like 0.1 would, or like 0.0001 would be 0.0001. G will select E if the exponent would be greater than the specified precision, default 6, or less than -4, and F otherwise. G does not print trailing zeros, whereas F will, and E and G display rounded values. F will display truncated values, which is an important thing. That's an important distinction. So with F, it truncates, whereas with E and G, they round up or they round down depending on what the value actually is. Slightly more complicated operation. Incidentally, the way that Python prints stuff is using these format tags. It just hides it from you. So the behavior specified in this lecture slide is, roughly speaking, applicable to Python as well. Random trivia. If you want to print the % character, you have to use 2 % characters. Slash, like the escape character and then %, that won't work. You have to do %, for some gosh darned reason. So, I don't think we have time to get into field widths, today because it's 10:19 already. My, how the time flies when you're having fun. I think that'll be our lecture today. So, any questions? I think next time we'll be able to wrap up formatting and then get into file I/O. This one's kind of long. It's like 58 slides in this one, which is like, normally I try to keep it like to one topic a week, but with this particular course, it's just kind of bowed outward in the middle because, you know, like I think the pointers one is like longer than I can usually. Yeah, 63 slides, which is well longer than I can cover in a week. So, but don't worry, because some of these guys coming up are shorter. Like preprocessor is only 21, so hopefully everything works out. Any motivational advice? University is existential dread. I don't know. I'm not sure I'm the best person to come to for motivational advice at the moment. But it's hard to be motivated when you have a cold, you know? Motivational advice. Let's see. What is the purpose of university? Right? Like, consider university. Consider it in the most general possible terms. Consider it's like, consider not so much its goals within society. You know, I've actually been sort of philosophically toying with the idea lately that society is kind of a false construct, because you can any societal good is fundamentally derivable from the good of individual people. So to me it's like, you know, we have this tendency to ascribe to society, like we talk about the good of society, or society this, society that. I think I personally think that, you know, we should talk about the good of people, individuals, rather than society in general, because society might be like a false Hegelian construct. But anyway, yeah. One side says to learn skills to be useful for a job. The other side is to earn paper to staple to a resume to get a job. The other side says to weed out the weak. Well, I'm not sure that we're doing as good a job at weeding out the weak anymore, you know. But it's, you know, let's put, so university is a phenomenal opportunity that you're only going to get once in your life to sort of become formidable, you know. It's easy to get lost in all of the work that's constantly being piled on top of you and not understand what the purpose of that work is, you know? It's like the purpose of all of the work that you do in learning how to perform the tasks required of you in the various pieces of work you have to do. That's almost even secondary to the overall goal, which is teaching you how to deal with complexity over an extended period of time, right? Because this is not fundamentally different from what will be required of you when you get out into the workplace, right? Learning how to manage a schedule is extremely important. It's an extremely important life skill, and this is what, you know, this is what you need to be teaching yourself right now, because up to this point, you know, high school teaches it, like the last couple of years of high school, you get it to a certain extent, depending on how much workload you take on. Like, if you decided in high school not to take a spare, as I did, I don't know if they still do. I don't know if they still do spares in high school, but you know, you learn a certain amount of how to manage time in high school, but when that rubber is really going to hit the road is in university, because it's going to come through in your grades whether or not you're managing your time effectively. Yeah, and as one of your colleagues states, learning how to learn. Well, it's not even necessarily learning, like, yeah, learning how to learn, like, but yeah, like, you know, you're going to feel as an undergraduate like an unreasonable amount of work is being expected of you. And to some extent, they still do spares. At least that hasn't changed. To some extent, that's true, right? Relative to, you know, as, like, it's been my impression over the years that, you know, high schools are sort of increasingly not really doing their job with respect to preparing people for university, which was, you know, back when the high schools had a university stream, the ostensible purpose of the university stream was to prepare students for being in university, you know, but, you know, they've now dispensed with streaming in high school, and I have no idea, I expect that to have coalesced and congealed into an unmitigated disaster within, you know, the next 5 years. Because, you know, not everybody who think, like, people are generally speaking pretty bad at knowing what they want, you know? And a lot of people, I think they want to be in a university when they actually don't. I taught in the college system for a few years, and there's really nothing wrong with it, you know? Like, a lot of people, I feel, maybe they forestalled that decision, but I had heard that the provincial government was doing away with streaming in high school. Unless they have reversed that decision, you know, it's possible that they're just letting the last sort of class get through, and then they're changing it in behind them. But, you know, if they're still doing streaming, that's good. But, you know, like, if your attitude towards university is, I want a piece of paper to get a job, then really I think you're better served by a college experience, you know? And, you know, what do I mean by streaming in high school? I mean, university prep, college prep, and then work, like, apprenticeship prep. Like, there was the 3 divisions, right? It's like the academic versus applied stream, and then it goes into college versus university streams. That's what I mean by high school. The provincial government a few years ago said that they were going to get rid of it. They made a big announcement about it. Again, I don't know if they rescinded it since, but, you know. But anyway, like, if all you want is a piece of paper to get a job, then, you know, what's wrong with the college system? Because that's what it's good at, right? They got rid of it in grade 9 math classes. Yes. Yeah, we'll see, you know, because it's like, that's kind of the push. Eventually they're going to do that for more classes. Yeah, and the more classes they do that for, the less, like part of the purpose, you know, of the education system is to find vocations for people, right? And, you know, essentially, you know, there's sort of this, nobody wants to say to any student anymore, listen, I don't think that you've got the chops for this. You should probably go here instead. Like, nobody wants to say that, but it's like to the point where they don't want to even acknowledge the difference. Like, there's like this pernicious desire to sort of like imagine that the playing field is completely level when it's not, you know? And as a result, people, you know, as they remove the streaming, you're going to get more and more people who've been streamed incorrectly because they've been left purely to their own, like, desires with respect to where they want to end up. And, you know, generally speaking, people are, like, not very good at knowing what they're good at or what they're capable of, especially when they're young. You know, it's like, you know, what little aid was being given to students in selecting a career path by the streaming system is now being further removed from them. So the decision about what to do after high school becomes yet more difficult because, you know, but anyway, like, I do like the college system. I've taught there before, and, you know, the top end of the college students, I would say, are competitive with the top end of the McMaster students. They just have different goals, right? Like, and you know, the other advantage of the college system, of course, is that you're paying, you know, a fraction of what you're paying for a university education. So what you're really, like, what is the value of the university education, right? It's having to deal with the workload, right? Like, once you have learned how to deal with this type of workload, those are skills that you're going to carry with you the rest of your life. It's also very useful if you're the type of person who is interested in pursuing academic research as a career. But yeah, even in the college system these days, although this is less true of the college system, the thing I tell people is, degrees don't get jobs, people get jobs. So if you want a job, it's good to start developing some extracurricular stuff. And I know, like, you'll probably have heard of this before, but, you know, it really is true that, you know, your degree is not, like, this piece of paper that you're going to be given, is it going to be about as good at shielding you from the hardships of life as any piece of paper would be from shielding you from anything, you know? Like, what you need to develop is you need to develop your own personal character, your own capacity for hard work, and, you know, your own intelligence. As one of your colleagues said, it learning how to learn. Like, that is the value in your education. Like, I remember some famous person had a quote once, I can't remember who, but the quote is, the education is what's left behind after you forget everything you've learned in school. Right? So, yeah. Would you say that it's necessary if you want to do engineering? Because I know more or less, if you're going to be a doctor or a lawyer, you need a university degree. Well, engineering is kind of a funny one, because to be a professional engineer, you need it for sure, right? But, you know, much to the PEO's chagrin, many people do engineering type work without being an engineer, especially in software. Like, this is not true with, like, electrical or, you know, certainly civil, very well regulated, you know, but, like, you know, and this might also be the fact that I'm kind of, like, you know, I'm mostly a software guy now, so I deal with telling people how to get jobs in software engineering mostly, you know, or computer science. But like, yeah, you are doing a professional program, so you know, in theory, you will you will be a an engineering professional at the end of this. But you know, like in the States, they don't really recognize, you know, basically engineer is a job title and not a professional designation down there, particularly in software. You know, like down in the States, you've got like absurd titles like like public relations engineer or customer service engineer. You know, it's like, so the term engineer means nothing to you basically, but yeah, so yeah, you need, if your goal is to be a P-Eng, this is the correct path, right? But you know, in order to be a P-Eng, you need to be able to land a job once you get out of here. So, you know, I know there were plenty of people in my year who did degrees in engineering and ended up elsewhere, you know? Plenty of people ended up going to college after doing their undergraduate. And that's kind of, I think that's kind of sneaky, you know? I think that's kind of sneaky of the university system to give people a degree that you then need a college diploma on top of to get a job. But, you know, it has a lot to do with the individual. That's what I say that's what I'm trying to say when I say that it's people that get jobs and not degrees. It's like, it's you know? So how do I do anything extracurricular when I'm dying doing the curricular? Well, it's interesting, right? Because it doesn't take much. Like, going to a couple of hackathons is like, taking one weekend and going to a hackathon is like actually kind of huge. And you know, in the spring semester we're going to be doing Delta hacks at the university, so you know, like, it's not even necessarily just I did some extracurricular here, I get my stamp to show you I've done extracurricular. Like, it's like, projects, you know? But you can get accredited faster, but could you do the practical exams with a college diploma? No. So, again, it puts you in a different category of... I do wish I had a weekend to spare. Yeah, if I had a weekend to spare, I'd probably just, like, crash on the couch and just sleep the entire time. But, yeah. You can get... Yeah. So, yeah, no. Like, if your goal is to be a P-Eng, you're in the correct program. If you would have been happy being a technologist, then, you know, college, right? Or a technician. I want to get a 3D printer for an robot arm project, but I don't know if it's just too basic nowadays. Nah, I'd say so. That's fine. Yeah. You guys, like, as far as I'm concerned, every mechatronics student should have a 3D printer that they learn how to use. Like, they're cheap enough that you can buy one yourself these days, you know? Like, you guys, I don't know, do they still do CAD in first year? Like, do you get a little bit of CAD? I know I had to, I took CAD as a fourth year elective, but, yeah. I don't know, you can get pretty far on, free CAD. Do I have one I recommend? Ooh, really just the cheapest one possible. Let's see here. I forget which. I have one downstairs, but I haven't. I've been having a mechanical issue with it, and I just haven't had the time to fix it. But let's see. I'm trying to remember. 3D printer. Cheap 3D printer. This is the guy. This is the one I had. I have. It's downstairs still. It's you know, I got a lot of a lot of use out of this one. But yeah, you know, it's not difficult. It's not like when I bought this thing, I think it was like on the order of $200, which is pretty good. I'm sure they make them cheaper these days too. But you don't need a big one. You don't need a fancy one. Like even just, you know, just to get you started with it, you know. But like this kind of thing, like I will warn you that 3D printers are a huge nerd trap. Like once you start fiddling with one, they can be a bit of a time sink, but like it's hobby, it's enjoyable, you know. You can make yourself little toys, you know. Make yourself figurines for your D&D group. All kinds of fun stuff. But yeah. Like anyway, I should let you guys go. See you guys tomorrow.